If education is meant to prepare you for the future, how do you prepare for a future that is so uncertain? We need to change our mindsets from trying to produce experts to trying to produce explorers.
It's quite profound. The guys have actually prepared a game, AI versus reality.
Okay.
And you gotta decide, is that picture real
Or AI?
is it AI? No, that's gotta be real.
I'm going with real. You're influencing me, but I'm going with real. No! Okay, we screwed. All of neural networks is teaching the computer to feel. This is the error of intuition. Computers are showing us the power of intuition. We've always had it as humans. It's been our superpower. It's been largely ignored by all the traditional systems, especially education.
The way the education systems have been set up is very much like a production line.
Humans are amazing explorers until you go to school and we beat it out of them and we say, don't do what you want to do what I tell you to do.
One of the biggest opportunities for AI is actually to transform the education system to what it should have been.
You know, learning is the most natural human instinct.
We often feel and decide something and then try to come up with the logic afterwards.
Kids don't lie on purpose. They always generate an answer that they think the parent wants to hear. We've made the most significant advances in computing capability, training a computer much more like we learn to generate an answer that they think humans will like. And suddenly, the computing based on intuition started to outperform all the logic. So think of all of these models that you're seeing as creative calculators.
But how can AI truly understand the human emotions behind creativity?
This is an incredibly complex problem to take PhD student 5 years to determine the correlation between one sequence and one shape. So we'd only mapped 100,000 of the 200 million.
Oh, wow.
They trained a program to have the intuition. Within 2 years, they mapped all 200 million.
Wow.
Google and all of these companies are now laying off jobs, essentially because AI is making them redundant.
So don't produce experts, produce explorers. If I gave you OpenAI's source code now, what would you do?
Jumping on something really exciting.
That's crazy. So are you like me, still wondering what the hell is AI? Are you afraid of it? Do you think it's a great opportunity? You got to stay tuned to this podcast. We discussed the impact of AI in education. We talk about how AI has already influenced the outcome of elections. And we go really deep into a number of philosophical topics about how AI is more human-like than logic-like. Join me for this amazing podcast with Ajit. Please like, subscribe. It's going to count. So to start off the conversation, the guys have actually prepared a game, AI versus reality.
Okay.
So we're gonna show a couple of pictures on the screen. We've got 5 seconds to guess.
Yeah.
And you gotta decide, is that picture real
or AI?
Is it AI? Okay.
Okay.
Okay, cool. Let's go, guys.
I'm going with real.
I've got real as well.
Yeah. Okay.
AI. Why did you think it was real?
Yeah, you know, the AI pictures that I've seen, the humans are not that good. That's interesting. That's AI.
You know what made me think it was real? It's got a bit of AI-ness to it.
Oh, really? What is AI-ness about this?
It looks very clean. Like the guy's face looks like almost perfect. And so I thought they were...
Man, this has stumped me because I
was
was fairly confident that I could get this.
No, I thought the guys are trying to catch us out. Okay, next.
Yeah. That's
Real.
Yeah, real. I've got real. No! This is proper, eh?
What?
Oh my goodness.
I got nothing for that.
Wow, that's pretty, yeah.
Is this Dali? Guys, what are we using for this? Who? Jen Craft. We got to put a link out to that.
Yeah, I wonder what the model is that they're using. But anyway, cool.
Okay.
That's really impressive. How the hell are we going to guess now?
I'm going to pick, the next one is AI. It doesn't matter what the picture is.
Okay, let's go. You know what? They're trying to catch us out, so I'm going with real.
I'm going AI.
Thank you.
Oh my word. So you got one.
No, because you see, this is interesting because if I hadn't seen the other two, I would have said this is the AI one because the AI pictures that I've seen, there's always, the realness of versus a photograph. So they look more like drawings than a photograph, or really good paintings. Really good paintings. So this is the one that I would say is really good painting. But wow.
Well, I can't tell the difference.
Yeah, that's pretty impressive.
Okay.
That's impressive. I'm tending not to believe these guys. It's that good. Yeah. Okay. Let's go.
I've seen this one, I think.
Yeah, I'm going with real. Oh, you've seen it? I should actually... Again, this would be one of those that I would choose as AI.
Yeah. But it's brilliant.
It's really good, right? It's really good.
It's brilliant. For all the photographers out there.
Yeah, this is proper impressive. Yeah.
Okay, let's go.
I'm going with real. I have to make sense in real a bit. Thank you.
Thank goodness.
What did you get? Real.
Real.
Yeah.
So you've got one.
I've got two.
I've got two. I've got one.
You've got one. Yeah. I'm winning on this. Are there any more? How many more? This is really good stuff.
I think there's three more. I think I've seen this one as well.
I'm going with real.
No ways. That looks like garam masala.
Yeah, the thing is, I think, the thing is here, we're just completely guessing, now. Because
the AI ones look real.
So realistic.
And the real ones look also, some of them look unreal.
Could be a little, Wow.
Okay.
And it's not making mistakes, because sometimes with AI pictures, you can see a mistake somewhere, and you can't. I'm looking for maybe, the typical one is the number of digits, number of fingers in a hand. They haven't really got that right yet.
Oh, really?
So a lot of the AI pictures, you want to look for where you can see fingers. But now, the pictures they're showing you, none of them will have fingers because, They're getting better at that.
What's interesting here is in photography, they call it the bokeh effect. So they focus it's a really sharp focus in a particular position in the picture, and it's all blurry in the other places. Right? Yeah, it's like...
Wow, that's proper. That's funny.
Okay, let's see the next one.
Okay. Oof.
No, that's gotta be real. That's gotta be real.
Yeah, I'm going with real. You're influencing me, but I'm going with real. No!
You're kidding.
Wow. Okay, we screwed. That's it.
I don't know about you, but I'm feeling a bit hungry.
Yeah. No, I'm I was fairly when you told me about this guy, I was like, actually, we can do this. I feel confident, but I obviously haven't kept up to date with the latest pictures or this whatever model they're using.
Okay.
Yeah.
Just because there's been far too many AIs.
No, this is AI. For sure.
I've got real.
You've got real. So you got a probability.
That was got nothing to do with the picture. That was just probability.
You see, so you see the people in the distance? I was like, there's something not hundreds of that parted. But it's real.
Yeah, it's real. Wow. Are there any more?
No, it's only one.
Who
Did
won?
I win?
No, I won. Oh, God.
The AI.
So much about being the expert. There we go.
Wow.
That's insane, actually.
That's crazy.
But honestly, it's not surprising because it's almost like every time you see something really cool and then you give it a few weeks, you come back and the improvement is insane. The jumps that they're making in terms of getting better.
Yeah. So this is obviously generative AI.
Yeah.
What is the difference between, there's these large language models that everyone talks about, ChatGPT, and generative AI?
No, large language models are generative AI. So same like the DALL-E and all of these, which are image-based, obviously, and large language models are also generative AI.
But only for language, right?
Yeah, but they're for language.
So what would have been used to create the generative model for these? Is it pictures?
It's image. So it's trained on images. So the large language models, I would say the fundamental structures are the same of the different models. It's just what are they trained on and what are they sort of structured to output. So essentially what this is every pixel on that picture is coded.
Yeah.
So when you feed into the model, you feed in this whole string of the pixels, and then it outputs a string of pixels.
Yeah.
So it's literally, it's also a language if you think about it. It's a bunch of code.
Yeah.
Yeah.
But I guess what's also interesting is that they've linked the language models to the image generator. So you can type in natural language.
Yeah.
Give me a lady on a sort of street selling, looks like crisps.
Correct.
And then
so what they're doing is the models are working together.
Yeah.
Which is like fascinating. So the example I'm excited about, so even if you just not look at generative AI, but sort of the deep learning models like AlphaGo and so on.
Yeah.
So what you can do is you can pair a generative model with AlphaGo, and then the sum is a great language model that also is the best Go player in the world. Whereas if you try to play, even though they might have been trained on a lot of Go games, the language models are not necessarily the best
at
Go because they're trained, the goal when training them is to make the most likely answer for a human.
So the combination
So the models work together. Yeah.
So the combination of models, multimodal, I think is the term, right?
Yeah. So multimodal means it's trained on multiple modals. So language and images and so on. Yeah. So multimodal is exactly that. It's training using different things, not just text. The language models are all just
So I guess
trained on text.
Smell and touch are next.
Yeah, that would be interesting. I haven't seen a lot of sensors out there for smell, like digital sensors for smell and taste. I guess if you could, it then becomes a form of training.
I guess always for me, if you walk into a supermarket and they've just taken the hot bread out of the ovens, that's the biggest selling tool I think there is. You can never walk out the store without buying
with smell,
because it's the impact it has. So they can put whatever images they want in front of you.
That would be interesting.
The sense
actually.
of smell
is
such an impact on what drives you to do something.
Yeah, look, I mean, I haven't seen sort of digital generators of smell and also sensors that pick up what you're smelling. I'm sure they are, but I don't know how advanced that is.
Yeah.
But especially with the training of these models, Jan, what they're doing now is, because you're doing multimodal and you're doing sort of combinations, right? Essentially, what our brain does when we are learning is we're creating a model of the world. Yeah. And it's the combinations of the different modes together that help us create this model, right? So when you're talking, I'm seeing your lips move, your body language, and I learn from the whole experience. And I think this is the next phase in terms of the combination. So it's not just pure image or pure audio or pure text. It's the combination used to learn, which is probably the best way to create a model of the world.
Yeah, because it is almost at least from a human perspective, a 5-dimensional world, right?
Correct, yeah, correct.
So we also did some research on some of the key questions that have been asked on Google, just in general, with regards to AI. So we've got them over here.
Okay.
So I'll good luck. I'll fire them at you.
I'll do my best. There you go.
So the question that we put into Google was, should we be worried about artificial intelligence?
Yeah.
So the first question that kind of came up was, what are the concerning social implications of AI-driven social media algorithms on societal behavior and the interpersonal relationships?
So look, AI is quite a broad term, right? I think it's come into a lot more general focus with generative AI and the large language models, ChatGPT, kind of brought it into focus. But if you look at overall AI, machine learning algorithms, everything that was used to drive social media, right? So what your feed is kind of the recommendation engines, is the first sort of first contact. Some of the guys call it first contact with AI. And it's very kind of basic, but it was those models that were kind of deciding what to send you. And we already know that they've made a massive impact. In some aspects quite positive, but most aspects quite negative in terms of polarization, echo chambers, the whole problem with society, not sharing a truth, they call it the post-truth world. So already those algorithms and that form of AI has started to create a big problem. So we already know that the way society is set up, we're very vulnerable. And then on top of that, if you add deep fakes, you add things like generative AI in sort of your personal friend, and getting into intimacy, getting into emotion. It is very scary. And I think the only real safeguard, because of how how easy it is to generate and how many people are doing this, it would be legislation to prevent, and some sort of security apparatus or watermarking, etc., so that we don't cross that. We're still aware when something is being generated versus being authentic.
So maybe let me take a few steps back and ask a sort of a question that was relevant. It's an election year for I think 60 countries around the world this year. So probably the one that was potentially, I don't know if it's a fact, but it seems to have been influenced by social media and indirectly AI, was the US elections
2016.
Yeah. A good couple of years ago.
Yeah.
Maybe just talk us through how that was actually done.
Yeah.
Just so that you can understand the impact of not only social media, but AI as well.
Yeah. So it's all about influence and how you can, how we're quite manipulatable as humans. Yeah. And it's a great example, the 2016 Cambridge Analytica sort of scandal.
Yeah.
So what they did was they identified the way the American elections worked is, through this electoral college.
Yeah.
And so you had to basically win certain key counties and then therefore certain key states in order to win the election. Yeah. Because there were states that were just blue or red in terms of Democratic and Republican.
Because unlike many other countries, it's not the total number of votes.
Yeah.
It's actually by state.
Electoral college.
Yeah.
And what was really interesting was that you could essentially, there was a swing vote group in every county, right? So they call them the persuadables. So people who are going to vote, but they're not decided on which side. Yeah. Everyone else is a done deal. You can't really manipulate them. But this group was a key group in the election, because if you could swing them left or right, you could essentially win a county. And if you won enough counties, you could win the state. And then if you win the state, you can win the general election. So they realized this, and they realized that actually we don't have to influence the 300 million people, 150 million people that are voting. We just have to find these, in each state, we need to find these key people. And what they did is they developed through, hundreds of, I think it was 100,000 surveys, a model that could model humans, right? Based on a certain set of data points.
Okay.
So by training this model, they could then look at your data points and decide whether you were Republican or Democrat. And they could also decide whether you were in the persuadable bracket. They could also see whether you were likely to vote or you were going to sit at home.
Okay. So let me just understand that. So they created something.
Yeah, a model.
Yeah, a model that was able to look at the 150 million people that were connected to social media in the US and categorize them into Democrat, Republican, or persuadable.
Correct. And even more than that, are you going to vote? Because you could be...
not everyone votes.
Yeah, you could be persuadable but not likely to vote. So there's no point in wasting time. So right down to that level. So they trained the model based on survey data, but they were fairly confident that the model could now accurately predict based on certain data points about you, which way you were going to swing. And then they realized also what was important to you, what issues were important to you. So essentially they could tailor make a message to you to swing you left or right if you were the right kind of persuader.
How many persuadables were there?
So it wasn't huge. It was in the hundreds of thousands. So let's say 100,000 could swing the entire election.
Wow.
In a state, it was like 10,000 people. It wasn't even massive numbers. It was the right 10,000. So what they do is then they send you a specific message to swing you. So let's say you were interested in gun rights and you were a persuadable. They'd send you a clip of Hillary saying, I'm going to take away your gun, or some sort of message around that. And that would push you towards Republican. And this is where this whole, you didn't win the popular vote, but you won the, the presidential election, the electoral college. That was a big thing.
Yeah.
And the thing is, you as an individual, because you're just being targeted amongst all this general noise, and there's no way that you know that you're actually being targeted. Yeah. And that message is designed to push you left or right. And so that was the first example of what I call mass manipulation, or what's generally known as mass manipulation.
Yeah. I mean, we had something similar in South Africa with white monopoly capital, right?
Correct, yeah.
Also a social media driven, based on
Correct,
analytics.
yeah. Correct. And then picking the right people to send the right message at the right time. So we're not as independent thinkers as we want to believe.
Yeah.
So when you're going to vote, it's not necessarily a free, independent thought. Look, we've always been manipulated. It's not new. Politicians have manipulated
over thousands of years.
Throughout history. But I think the tool makes it so much more targeted, so much more efficient, scalable, and so in all of those aspects, there's a lot of people saying that 2024 might be the last human election, because if this kind of technology becomes ubiquitous, how do you ever have a democracy? I know this is pretty scary. It's pretty scary stuff, but that is.
You kind of alluded to my next question, but I was going to say that was 7 years ago.
Yeah.
And a lot has happened between then and now.
Yeah.
And as the sort of question, the societal behavior and interpersonal relationships, specifically. So just if I want to understand, that wasn't illegal.
No, it wasn't. So what was illegal and what they got actually sort of nailed for? So Cambridge Analytica as a company had to close down, and it was a massive. In my opinion, it was a scapegoat, because the behavior wasn't shut out. It was more the individual company. But what the big scandal was, this privacy thing, where they were giving your name along with all this data around you. And the truth is, the name really didn't matter. Do I care whether you are Yanesh Naidu voting left or right, or do I care whether I'm swinging the total vote? Yeah. And they don't. So actually, anonymity.
They got nailed for something that actually didn't have an impact.
Correct. Well, they did mass manipulation, but I think at the time it wasn't illegal at all, because they were quite open about saying this is their methodology. It was a form of
I remember there was
data
a presentation.
mining.
They were boasting about.
Correct. Yeah. So it wasn't seen as illegal until obviously we've got this example of how detrimental it can be. And by the way, the U.S. election was the last of about 5 of them that they had manipulated.
Oh, really?
Through in different countries along the world.
Do you know the countries?
I think it was Jamaica, if I'm one of the Caribbean countries. And that was amazing. I mean, that they went to a lot of detail. There's a whole documentary on how they've done it in different countries.
We must actually get that link and share it.
Yeah. And I mean, there's a movie called The Great Hack, or documentary on Netflix, and that talks through all the different interventions they had. But again, I don't think the practice has gone away. I think because it's too easy to do and too powerful if you do it. And almost impossible to regulate.
Yeah, which is the next question. How do you ensure global AI ethics and to prevent bias and marginalization?
Right. So the bias side of things is actually not as, in my opinion, not as big a problem as made out to be, because bias is inherent based on the training data. Yeah. And if you've got a model that has bias, you can test for it and correct it, right? Because, it's easy to identify because the model will perform in a certain way, and you can test for that bias, and then you can then train it out of being that way biased. And again, this, my opinion is also based on what I've heard other experts talk about. It's not my sort of conclusion. Humans are much more difficult to get bias out of, if you think about it, right? Because how do you, people will say what they think you want them to say rather than their true biases.
Yeah, of course.
So if I were to choose between getting a machine to make a decision based on bias versus a human, I think the machine ultimately could be better and could be less biased. So I think that's a short-term problem. In terms of marginalization, this is a massive problem, because right now there's actually, from an ethical perspective, there's this kind of conundrum that we're under. Yeah. So there's a big move for open source in the AI space to let AI become, or these models be distributed at scale. And there's a lot of motivation for that, because one, things like the internet is actually based on open source software, and the development and sort of the innovation at scale, and this kind of do-good mindset has been very, very successful. Yeah. It also democratizes it to a certain extent, because you no longer have just a few guys who can afford it to have that. But at the same time, there's a security risk, obviously, because the more distributed it is, the less controllable it is.
So I just want to take a step back there, just because I think we talk very casually about open source.
Yeah.
Describe what that actually means to a layperson. Like, why is, when we say it should be open source, why is that important? That was a big, topic around open AI. Is it open source? Is it not? And why Elon Musk left the whole open AI structure, because he believed it wasn't open source. But maybe I think it's important to kind of explain what does that actually mean and the impact of that.
Yeah. So open source is, it's quite simple in terms of how I understand it, is that it's you release the code. Yeah, so you generally release the internal workings, the structure, what we would otherwise protect under IP. You release it at scale. And it's almost like no one owns the IP, or everyone owns the IP. And everyone then builds on top of the open source, and then they contribute back into that pool. And essentially how people fund this over time is they become experts in implementing that code rather than the code itself. Do you know what I mean? So I don't sell you the code, I sell being able to implement that code. And it's a great model. Why? Because it allows for everyone to contribute to it. It's not just you and a bunch of experts that you've now hired. It's everyone contributing to it.
But I still think that everyone that could potentially contribute is still small. So yes, it is, if the concept of open source makes sense, because there's no commercial barrier.
Correct.
But there's still a barrier.
In terms of, how do you mean,
in terms of
capability?
Everyone, there's a capability barrier, there's a access barrier. I can't think of a child in some rural area in South Africa having access to, even if OpenAI was open, what does that actually mean?
No, but it opens the door to that child actually getting there. Yeah. So there's a lot of, like, it's almost like, you can learn on the internet about how to code, and ultimately you can, it's not that easy, but it's possible.
Yeah.
Yeah. So the open source is this idea of releasing to humanity, and that was very successful. Now, as I say, in the AI space, there's two sides to this, right? It's giving everyone the information, and then ultimately they can, do stuff with it. Yeah. Or keeping it with the very few people that become very powerful. Now, the risk of doing the second model is that it does become a big sort of...
you're giving everyone a potential gun.
Correct.
Or you're giving everyone gunpowder.
Correct. Yeah.
They could make a gun.
In the distributed model.
Or they could use it for mining.
Correct, yeah. It's much harder to control. So it's about giving some people too much power, and then the rest get marginalized, or giving everyone same kind of power, not necessarily as, you obviously investment and experts is an advantage, but giving everyone the power and then risking the fact that you can't control it.
So I'm going to deviate from these questions here, because I've got something that I want to ask you.
Okay.
If you're in the ed tech space,
you're
very passionate about that.
Absolutely.
If I gave you OpenAI's software source code now, here you go, AJ. What would you do?
Yeah. So look, I mean, just I want to clarify that. So OpenAI is allowing people to access their model. They're just not releasing the code, which is the parameters. Yeah. There's a lot of companies like Meta, which has released their parameters, right? So this has already happened. The big thing about OpenAI, for example, and all these big companies, very few people have the sort of resources to train these models. So it's almost coming up with that super code. But once you've come up with the super code, you can let everyone know the code or decide not. Yeah. So what would I do with a model like OpenAI today? I mean, there's examples of that right now because Llama has exactly done that. It's released the
Llama's is Facebook.
Is Meta.
I mean, yeah,
Meta's model, and there's quite a few. In fact, and there's a lot of models. I think there's I forget the name of the site that actually hosts models that you can download. So it's not rocket science per se. So what are people doing? So that's already, the question is almost rhetorical because that's already happening. And what?
So then, sorry, why would Microsoft spend, was it $19 billion on something that they could have got from Meta?
So I think they bought the sort of the future development. Okay. So they're more interested in GPT-5 and where this trajectory is, their expertise. Yeah. So
they bought the talent.
Yeah, they bought the talent and sort of all the work that has got, like I say, how to train a model is very different from how to use a model.
Yes.
Yeah. Using a model, almost everyone is using models now, and they're coming up with creative way. But they talk about is these foundation models. Yeah. Building them is a real big skill.
Okay. Yeah, okay. Sorry, I disrupted your train of thought. You were saying my question was rhetorical because everyone has access.
Yeah. So what are people doing in education? I think the biggest, everyone's known for a while, for a long time, that a personal tutor is much more is the most effective way of teaching. Because the learning is or the teaching is very customized to the need of that individual student. Yeah, and there was studies done many years ago which has proven that a personal tutor can help you teach. The learning rate is much higher. So
the studies done with a human personal tutor.
Correct. Yeah. Okay. Yeah. I mean, the difference between being taught in a class or being taught yourself. Versus a personal tutor. The personal tutor wins flat out, yeah?
That's the only ways I got through school.
Correct. So and the difference, yeah, of how much of a difference it makes. So and this is not individual based. This is kind of with all of us. This has been the study. And so I think most of the big efforts in AI is to create that personal tutor for you. So the personal teacher who can customize the learning for you, tell you the right thing at the right time, etc., and get you through. So in the edtech space, that's I'd say we're getting there. We're not there yet, but these generative models have
Hasn't Khan Academy also just released something?
So they've got Khan Migo, which is close, but not anywhere near like having a personal tutor full time. It's subject based, and they have certain kind of things that they've tested and released and so on. But it's not far. It's not far at all.
Oh, so you're saying they haven't gone that far?
Yeah, so they've released Khan Migo. Yeah. They've already released Khan Migo, and it is like a personal tutor. But I don't think it's a general personal tutor on everything.
It's on its way.
It's on its way, yeah. And they're learning with it and obviously overcoming some of the challenges. But I think that's the kind of the coming soon.
Yeah, okay.
The current thing that most people are using AI for is, the best way to teach a child. So personalizing everyone's learning path, yeah? So it's not interactive as a personal tutor, but it's like, okay, I failed this, and then it will give me more lessons on that, sort of that adapting learning space. And that's already general. Hey, there's a lot of companies doing that.
So maybe if we could take a step back on that education thing, because the last question was, how will learning look in the future with AI? But this is something that you've taught me in the way the education systems have been set up.
Yeah.
Was very much like a production line.
Correct, yeah.
So maybe just describe that and why customized learning is so important.
Yeah, so there's...
Your words were, we tried to make humans robots.
Correct, yeah. Correct. So it's all about standardized output. So we had come up with a set of skills and criteria that every person entering university needed to have. And then we did, sort of make it a little less general, where if you want to do engineering, you needed to have these skills. And if you want to do medicine or whatever. So there was some customization, but late customization. And that's not even individual, that's sort of into buckets, So the entire system was designed around knowing exactly the skill sets that you need. And there was almost zero personalization. So it wasn't about what you were interested in, capable, what your aptitudes were. It was very much around, can we make you a standard product?
And produce as many as we can.
Correct.
Yeah. Mass production,
yeah. I mean, we all know that the education system was designed for the industrial age, where we needed a whole bunch of workers that did the same thing and were very clearly in that space. And it didn't change, doesn't matter where in the sort of cognitive change or work, sort of white collar or blue collar space you were, it was very clear standardized outputs, What's really changed, in my opinion, is that firstly, the world of work is going to change in a massive way. Nobody knows what the future of work is going to look like. So what do you train children for? And I think what's going to happen is you're going to focus much more on the individual, because now the technology is actually able to facilitate that. You must remember that the systems are also designed for efficiency. Yeah.
Mass production.
Correct. And how to do that standardized output in the most efficient way. And so we just didn't have the technology. Even if we wanted to personalize education, we just didn't have the systems to do that. Whereas now we've got the systems to do that, and we've got the fact that we don't know what the world of work looks like. So my hope actually is that we start to focus more on the individual and what they're interested in, what they're capable is, and use education not to achieve an output, but to augment the child, which is, in my opinion, what it should have been in the first place. I think it's all about each child and what they can, and sort of unlocking their full potential. So I think education, my hope is that it will get there. One of the things I stay away from is predicting where things are going, because I just feel that it's too uncertain at the moment.
But I think if I'm understanding what you're saying correctly, is probably one of the biggest opportunities for AI is actually to transform the education system to what it should have been.
Yeah, absolutely. You said it better than I could. It's to disrupt it, and we to be honest, guys, I think we all know this, that the education system hasn't been fit for purpose for a long time.
And it's across countries.
I
mean, there's, I guess, a few, Finland and maybe one or two other countries that kind of stand out a little different, but by and large, most countries are still mass producing people out of school and out of tertiary education.
Correct. And I think it starts with the standardized output. Even Finland has a entrance exam that is standardized. So it doesn't matter, the pedagogy, the styles of teaching are very different all over the world, but the system is based on knowing what you want as an output. And hopefully we'll get to a space where we have the courage to admit we don't know what's coming, and therefore we can't design an output. If you tell your child, gone are the days where, you tell your child, grow up and I want you to be a doctor or an engineer or whatever, because what will exist in the future, we don't really know. If you know the technology that's there today, you'll fairly be convinced that we don't know what's coming. So
the doctor certainly will need some engineering and software skills in the future.
Well, I don't even know, the definition of doctors, we'll come to that, but the definition of doctors, I think, can change.
Dr. Nier.
Yeah. And it's really exciting. In my opinion, it's really exciting. I think there's massive change across the world. And if education is meant to prepare you for the future, how do you prepare for a future that is so uncertain? And my opinion is that we need to change our mindsets from, trying to become or produce experts to trying to produce explorers. Knowing that we don't know what's coming, what are the skills they need to be able to explore an unknown?
That's quite profound. So don't produce experts, produce explorers.
Correct.
Yeah. We've had a few great explorers in the world.
Yeah. And who are the best explorers? A 5-year-old.
Yeah.
A 5-year-old is the best explorer because everything they do is about exploring the world around them. They're still building their world model, right?
Discovery, yeah.
And they're very comfortable doing it. I often say, kids put everything in their mouth, and people, that's quite a profound thing that they're doing, because it's not because they're perpetually hungry. It's because they actually want to feel how this pen tastes, because they're exploring. They want to feel it, they want to see it, they want to look, manipulate it, and then they want to taste it. Because the sense to them is just another way of interacting with the world. So humans are amazing explorers. So as I say...
Until we go to school.
Until we go to school and we beat it out of them and we say, don't do what you want to do what I tell you to do. Because I know what's better for you. The truth is we don't. And you know what? It takes us to be courageous, to really admit we don't know what's coming. That's a harder thing to do.
It's easy to say, but to accept is a different thing.
Yeah.
So, just staying on the education front, I think that there's also, at least I have this perception that yes, AI, this customized learning tutor in my pocket, as a lot of people kind of refer to it as, is for Western affluent societies. But we have the majority of the population of this planet and the future population of the planet in really underprivileged environments. How do we use AI and education to actually, what do we do for them?
So why is it, it's more for them than the affluent population?
I agree, the need is there.
Yeah, the need is greater.
But the access
is not there. What's amazing about these models actually is that once you build them and you train them and you've got this trained model, they're actually not that big. I think they're going to fit on phones and they're going to be functional offline. So to be honest, I think this is one of those areas where technology is getting to a place where the disparity between the rich and the poor is going to be much less. And rich children may have personal tutors today, human tutors, whereas poor kids around the world, the majority of the world still unfortunately won't, but at the same time they may have access to personalized tutors at scale. There's it was a book where, I forget the name of the book, but it was this young lady's primer, which is this idea of an offline device that can be your personal tutor and teach you based on the context that you're in and the need that you have right then and your personality. So I think the biggest impact in terms of transformation is going to be in the poorer half of the world. And I think we're just lucky that these models, the tech is actually not that hard to distribute. It's probably, we've already distributed phones at scale, and if we can do that, we can probably distribute this tech and probably be slightly easier than phones.
Yeah, because it just sits on a phone.
Correct.
So you say we'd be able to put one of these models which ultimately becomes your tutor on a phone and distribute that, because the phones are pretty much everywhere. Right?
Yeah,
smartphones.
Yeah. So I actually think in that sense, this is sort of a great sort of, we got lucky that these models, look, to give you a sense, I think GPT-4 is a terabyte in size.
Okay.
Which nowadays you can fit on a tiny thing. And some of the models are even as small as 13 GB.
Wow.
And they're functional. So people are working on that to make them smaller and still as, if not better, functional. I don't think there's any models in the world that are small that are good as GPT-4, Llama, and the rest, but they're getting there. So
and the cost of space is nothing.
There's nothing.
You get 1 terabyte.
So it's such a strange environment actually, because you're getting really powerful tools that are almost ridiculously cheap to distribute. They're incredibly expensive to make. Very few people can make them, but there's enough for people making them to not be totally monopolized. And then in reverse, they're incredibly cheap to distribute. And that's not far away. That's in the next 6 months.
Almost like if you said 20 years ago, you'd have the internet in your pocket. You'd think that's...
No, I mean, we were talking a little bit about medicine. So most people see the biggest sort of disruptions in the short term in medicine and in education. But if you could have a better doctor than you on your phone, offline, in the middle of anywhere.
Yeah. That knows your context. That's been monitoring you for the last while.
Correct. And I think this is the other thing, the personal side of it. It's like you have these general models that then also train what we call context. So what goes into the model on an ongoing basis is your personal data.
Yeah.
So
I mean, I've got 2 devices on me, my Whoop, my Apple Watch, and every month I put on a glucose sensor, which you know, and my phone has all of that information.
So imagine talking to a doctor who every time you ask them anything, they quickly read all of your history data.
In a few seconds.
In milliseconds. And then has a better intuition than any doctor around there because they've seen 100 million cases. They were trained on 100 million cases.
It's crazy.
For every one.
Wow.
It's insane, right?
Crazy. So you've been on a roadshow over the last couple of months talking about AI to quite a few people now. Well received, people love it. I've seen the feedback, so well done on that.
Thanks.
And obviously you've prepared a couple, not the whole presentation, but a couple of slides from that presentation. Can we have a quick look at it?
Yeah. So I just want to give you some context to the presentation that I'm going to share with you. So I think what I try to do in these talks and what I'll try and do now quite quickly is just land some concepts that are quite important to understand. That if you understand them, then AI and what's happening in the world makes a lot more sense. It's easy. It becomes a lot more easy to digest. And that is essentially the journey that I went on. And once I got those concepts, everything else was easier. And so what I'm going to try and do is talk to those concepts now, and then we'll take it from there.
Cool.
This is the fundamental reason we're doing what we're doing in Odin Education. I see this as the great equalizer, and not only equalize, but almost, leapfrog everyone, starting with the poor, to a new sort of stage of education, and ultimately medicine in another field, but my field is obviously education. And this point of saying that we're lucky that this tech is so cheap and easy to distribute. We just need to put the infrastructure down to give access to these tools to learners everywhere. And essentially, that's my day job. That's exactly why I'm passionate about this tech. I'm passionate about AI, is to put this in the hands of everyone. And I think it's an inevitable future. We're just going to be first.
The 2 sort of questions that popped into my mind were, I guess because in underprivileged environments, there is not much to change from. Adoption would be quicker, I would imagine.
Yeah, and it's funny, when we do the presentation of the tech, a lot of the sponsors will say, hey, can I get one of these for my kids? And my answer to them is, you're not underprivileged enough, and it's funny because you're right. I think the appetite for adoption, if you've got nothing else to change and your environment is in that space, you're mentally ready to adopt. And you have a broken system, so you don't have any sort of barriers or change mindset required because the system is already broken. Implementation into sort of privileged schools, into a lot of schools in the West, a lot of the advanced countries, is that they've sort of built expertise on the legacy education system, which is a lot more embedded and a lot more structured. So I think the opportunity for the poor to leapfrog is significant.
Yeah.
And it's also, again, why we're focusing on that part of society. Plus, we want to see societal change. But I think it's also the lowest barrier for us to enter and the most impact.
Yeah. That's amazing. Makes perfect sense. Nobody's stuck in the mud.
Correct. Exactly. It's like it's why, for example, launching cell phones in places that didn't have landlines was so much easier. And this is the education version of that.
Shows you that you can jump to digital before you didn't need analog.
Correct, 100%. And so we can jump to personalized tutoring.
From textbook to personalized tutor.
Correct.
Or you can skip textbook.
Correct.
Because in many of our environments,
Yeah, they don't
textbooks
even have resources. I think the biggest jump is from standardized outcome to personalized curriculum. That's the biggest.
That
jump.
is the opportunity for underprivileged kids to leapfrog
Correct.
privileged kids.
Correct.
What is the I think you've got a few thousand kids on your platform.
Yeah.
What is the feedback like?
It's amazing. I think the thing that excites us the most is that the learning is self-driven. I always say this, learning is the most natural human instinct. Our 5-year-olds are not told to learn. They learn spontaneously throughout the day at every opportunity they can. That's why they put their stuff in their mouths. Or 2-year-olds put stuff in their mouths. Maybe 5-year-olds have been trained out of that. But it's the most natural thing. And somehow we've began to unlock that passion in children out there to learn, because everything they do on our infrastructure is learn, and they're doing it voluntarily 1 hour, more than an hour a day. Now, if you think about that, to get your child, any privileged parent, to get their child to focus and learn something for 1 hour a day after school, what would that take? And yet, when you just change what education means, you allow the learner to drive themselves, you make sure it's augmenting what they're actually passionate about from a positive education space, they'll do it themselves.
Yeah.
So we are competing with YouTube, and kids are, instead of being on YouTube for an hour a day, they're spending an hour a day learning something. Isn't that amazing?
Yeah, that's amazing. Well done.
Yeah, we're very excited. It was a theory that's actually being validated at scale, which is why I'm really passionate about where we're going.
Awesome.
Okay, so as I said, these are concepts that are going to help people understand what's happening in the AI space, because it's important to understand this journey, right? So, Jan, what's that?
It's a cat.
Okay, so I do this in the talk. I ask people what's that, and they look at me funny, exactly like you looked at me now. But it's quite an important thing, right? To say, why did you say that was a cat? Have you seen this picture before?
No.
Okay, but why did you say that was a cat?
Because it's a cat.
Why? Why do you say that it's a cat? What makes it a cat?
It's a trick question.
No, I'm genuinely asking. Like, you had an immediate response. You knew the answer, and I've yet to find someone in all the audiences to get this wrong. But so it doesn't matter who the person is out there; they can pretty much tell you that it's a cat, and they've all never seen that picture before. So how are we doing this? So why are you saying that that's a cat?
Look, I could come up with some logic that explains that, but I'm imagining I've seen cats before. I've learned that is a cat, and I can compare what I've seen in the past to this and connect them and say it's a cat.
Okay, so you've just described the two major schools of AI. So the first one was there's some sort of logic or set of rules that makes you identify that as a cat.
Okay.
Right? So imagine it has 2 ears, it has eyes, it has whiskers, it has, and you build a set of rules, and if it tick, 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 that's a cat.
Yeah.
Yeah? Essentially, this is how 60 years of AI development happened. It's called symbolic AI, and it was trying to mimic our logic process of identifying things in the world and how we interact. But the truth is, there was another school of thought called neural networks, which said, actually, you don't have to know the logic of why you thought it was a cat. This is why you were looking at me like, what's wrong with you? That's a cat, right? Because there's the other school where you were trained on what a cat was. And so you intuitively knew what a cat was. And what's happened is we've gone from, and all of programming up till now has been very deterministic, or until sort of the last 15 years, right? The general programming out there is a bunch of rules that the computer follows. Symbolic, yeah. This is symbolic AI, but essentially it's programming in total, yeah? You create a set of rules, if then rules. If then is the kind of, if it is, then do this. If it isn't, then do that. And we suddenly realized about 15 years ago, and there was a combination of things that happened. So firstly, computing got to a certain point. It was like almost a tipping point where suddenly we could see the power of neural networks. And we had big data sets that we'd never had before to train. So this kind of combination of large data sets and just enough computing suddenly unlocked this world of neural nets, which now is training a computer much more like we learn rather than this logic-based.
Okay.
And this is really important to understand, because there's, we almost trained to think very logically, but actually humans spend a lot more time in the intuitive space than the logic space.
Yeah, and I think we often feel and decide something and then try to come up with the logic afterwards.
100%. You said it right, feel. So all of neural networks is teaching the computer to feel. Think about that statement, right? So we've kind of crossed over this kind of hard logic, deterministic, output-based systems to systems of exposure and intuition, which is actually the next slide. So if I'm going to just quickly go to the next slide. And essentially, there's been over many years, there's been this dominance of the left brain. This, I'm sure you've seen this picture before.
Yeah.
Left brain, right brain.
Yeah.
And our entire education system actually subjugates the right brain, the creative, the arts. They're always kind of the bottom feeder subjects. And what are the top subjects? Those that need critical thinking, that need, deterministic outputs, that kind of thing. And what happened about 15 years ago is we had computing based on these two theories, and suddenly the computing based on intuition started to outperform all the logic-based intuition. And this is the key thing where, like you say, we feel something and then we build the logic as to why it is what it is.
Yeah.
Computers are outputting feelings. I felt that was a cat. And we don't know essentially how it's actually feeling. We just have trained it over many, many years, and it's starting to perform. So this is a big, it's hard to understand because we're so used to
the logic.
I'm
almost like not wanting to believe you.
Correct. We are so used to logic. We trained, this critical, I call it the tyranny of critical thinking, right? There's a tyranny of critical thinking in the world. We think everything is logic-based, whereas most of the human experience is not logic-based. Yeah? And another thing is, it's not just the art or love or emotion. It is even in some of the most complex, sort of practical applications. And let me give you another example. There are the stock exchange.
Yeah.
People for years have tried to come up with rule-based algorithms to beat the stock exchange. Yet most traders will know, top traders, that they believe in their gut and they have this intuition on what to bet on.
Yeah.
And those guys have developed
they've honed that skill.
Yeah. And it's a real skill. It's not honed in school. There's no intuition-based learning at school, but it's actually a very, very human way of learning. And it's probably our biggest human attribute. And it's the first time in sort of technological history that we're trying to translate that power into the digital space. Now, let me give you an example. A great doctor has a great intuition for what the problem is.
Yes.
But in medical school, are they really trained on that intuition, or are they trained on the rules?
It's the rules.
Correct.
Yeah.
So it's almost like the education system and how society is built is on a misunderstanding of how we work.
Yeah.
Because the most successful humans out there are much more
non-logic.
Well, it's not bad logic. It's just they're not based on logic. They have a gut feel that gets them to navigate the most complex environments. And in the sort of programming space, what we've realized is that this kind of intuition-based programming is much better at the more complex the environment is.
The people that look at these famous paintings and decide if it's a fake or not,
Yeah,
they can tell, but they can't explain why.
correct. And exactly. That's paintings, but let's go into some of the more areas where people may misunderstand that it's much more logic based, like language per se. English, I used to struggle when I was being taught the vowels and, because it's almost every rule has an exception.
Yeah.
Yeah. There's silent letters and it, like grammar doesn't make sense.
That's why I come up with my own spelling.
Correct. But from a pure logic perspective. And so think about that. If you're trying to train a rule-based language outputting machine, that's why it was so hard to do. Whereas if someone can just be exposed to a lot of text, or the machine is exposed to a lot of text as babies are, they figure out language, even though it doesn't actually always logically make sense.
Yeah. So let me just try and summarize. You're saying there's been, over the last 15 years, a change from a logic-based approach to computing, where we now have computing power and large data sets that allow us to be a more intuitive-based type of computing.
Correct.
It's a complex concept to get.
And that's why I'm trying to, what's amazing for me is the big sort of mind-boggling shift that all scientists made at that sort of 15-year ago mark was they suddenly realized that in very otherwise logic-based spaces, the intuition was beating the logic. In fact, in the most complex logic spaces, the intuition was beating the logic.
You got to give me some examples.
Okay, so
because I'm not believing that.
No, but the language models is the first thing. Siri was originally based on expert AI systems.
Yeah, right.
Yeah, and an expert AI system was symbolic.
Yeah.
So they literally tried to take everything you say, right, and deduce rules and symbols and manipulate them to make understanding. And suddenly, a model that we actually don't even know how it's doing, we just train it with a whole bunch of inputs, and it's structured in the same way that our brains are structured in terms of neurons and synapses. Look, I'm making it very simplistic, but it really is conceptually not that far from this. Suddenly is outperforming, 20 years of Siri development and IBM Watson and, all these expert systems. And so, and for me, the most exciting part is what does this say about how we think as humans and our power? And I go into this a lot more in the talks, but it's a concept and it's hard for people to understand because, and this is when a large language model makes a mistake, right? In our logic-based systems, if something is encoded and makes a mistake, it doesn't work.
It's broken.
It's broken. But if a great doctor made a mistake once, it's not a great doctor. He made a mistake. And what does he do? He learns from that mistake, puts it into his training data set, and becomes more. So now suddenly, when you look at these models, you can't look at them how you would look at programming logic or how you've been trained.
Yeah. I at least for me, I'm schooled that way.
Correct.
It's very difficult.
Schooled that way.
It's very difficult to change your thinking.
Correct. And intuition has been a largely ignored aspect. And what I'm saying is, if you really think about it, intuition is probably a fundamental to our human progress and has been a part of intellect that we have completely almost ignored, and I think actually what computers are showing and the latest developments is showing is actually that needs to be a big part of how our understanding of how we think and how we can progress. It's fascinating.
Yeah,
I mean,
completely.
And the other thing is intuition works best at highly complex environments.
Yeah, like our brains.
Like the stock exchange, like how we interact in language and love and emotion and so on. So all we've done is we brought that into the digital space, and this is what's blowing us away at the moment.
Wow. And you say that's in the last 15 years, eh?
Yeah, last 15 years of AI development. And there was a tipping point because we kind of knew there was a lot of people working in that before that, But there was a tipping point because the hardware and the data set hadn't caught up to the right moment. And it's almost like once we crossed that threshold, suddenly we've realized this whole new field of
Opportunity.
of thinking even in the programming and the opportunity that comes around. So anyway, I really want to show this. It's something that again, like it's hard to really understand, but this is what's now changing the kind of applications you can use it. So the best way to think about AI and an AI tool is wherever your intuition plays a big role. Like, I mean, the first example was identifying the animal or the image, to any other part of the world or the human experience where intuition plays a big role. Let me give you another great example. We tried to build rule-based autonomous vehicles for
and we failed.
Years and years, and we failed because the natural world has it's so complex, and yet a 17-year-old, can learn a rule book that's about this big, and somehow develops the intuition to drive. So when you brake suddenly or you avoid an oncoming collision, it's not because there was a book or there was a rule in the book that says when a car is coming opposite you turn left and so on. And this is why it was so difficult for us to program this, because you almost have to know every
scenario,
scenario,
which is impossible.
And so that's why this kind of AI, neural network based AI, whether it's generative or not, deep learning is the field of computing that's actually going to help us cross that what I call the complexity threshold, where logic fails and now you need a guide.
Same things happen in computer vision in general. We had very logic based, measure the color of the pixel and make a decision. Now it's learning and creating a model.
And my sort of reason to say this is don't think of it as a program.
It's hard.
Because you always, when you think of applications of AI, when you think of everything that we've learned to now, it's always been if then, very rule based. And all you have to look to say where can this work better is where humans are thriving.
Unfortunately, I've been tainted with 25 years of education.
Yeah. Right, let's go to the next. Cool. Do this again. All right. So I think this follows on really nicely. The reason a lot of people say that, ChatGPT is like a calculator for language. I think if you understand that there is no right answer in language, that it's very intuition based, that it's learning based, that failure is not bad. So just think about that, right? Our schooling system teaches us failure is really bad, whereas in a model, anything wrong is part of the training data.
It's an input, yeah.
Yeah, it's an input. And you almost, you kind of set up to be wrong all the time till you're right.
Yeah.
So when you look at these models like ChatGPT, it is a calculator. It is augmenting the human process or the human sort of endeavor. But it's doing it on the right brain side of things, not the left brain side.
Yeah, how it's doing it.
Correct, yeah. And it's behaving a lot more. So if you were to apply a neural network to, let's say, the stock exchange, it's guessing as much as a very good stock trader is guessing. So therefore, it's not always right. But it can be as good as the best.
Yeah, the more mistakes it makes, the more training it gets.
And what is it developing? It's not developing the right answers. It's developing a better intuition.
Yeah. Yeah, the connections and the...
Yeah, a better intuition, like humans do. So if you look inside the model and look for the rules to break the stock exchange, you won't get there. Mm-hmm. All you get is a set of numbers, of parameters that are actually training. And I think that why I'm so excited about sort of talking about this is once you understand that, you become a lot more open and a lot more sort of understanding of these models.
So it's almost like if I've taught or I've learned on a data set.
Yeah.
And just because I've been taught on that data set doesn't limit what I actually know.
Correct.
And can infer if you want.
So you just described generative AI. That's exactly what it's doing. It's generating based on the training data, inferring based on the training data. So you see, I think this is really important because now you can like understand the rest, and it's going to be a lot easier. But so think of ChatGPT and all of these models. GPT is the language one, but DALL-E and all of these models that you're seeing as creative calculators. And the key thing is not to think of it in the calculator space, but to think of it in the intuition space. I know it's a hard jump, but trust me, let that sink in, and over time you'll see the sort of relevance happen again and again and again as you get exposed.
I like the ChatGPT logo on the calculator.
Yeah, just some fun. So this is probably for me the best example of how again our education system has made us think of arts and drama as not intellectual, and science and
Maths and
maths
engineering.
as being all the intellect, and logic, and this hard logic, tyranny of logic. This is a incredibly complex problem that it's called the protein folding problem. I'll give you a quick talk about it, that science could not solve. Okay, so essentially what it was the world is made up of proteins, or the living world is made up of proteins. Proteins are the basis of all life. Yeah, they're the kind of little mini machines that work in your body. Known to man is 200 million proteins in sort of the known living universe.
So 200 million proteins.
Proteins is known to man. And we know one thing from a logic perspective. We know that if you arrange in nature, if you arrange a certain sequence of amino acids, they spontaneously fold to a specific shape. Okay, there's not that many amino acids. I'm not sure exactly the number, but if you arrange them in a certain sequence, they make a certain shape. And the shape is really important to the functioning of the protein. So a certain shape of protein that describes how it functions, how the mini machine works in the world, right? So I'll give you a great example is the virus, the COVID-19 virus. Remember the spike? That's a protein spike.
Yeah.
Okay, so that is the shape that determined the functioning of the virus. Yep. So it would be very useful for us to figure out this relationship between the sequence and the shape, because that will help us understand proteins and their function. Because you can sort of break down the sequence, but you can't automatically calculate the shape. Yeah. And scientists have been trying to figure out this paradox, right? Because in nature, a certain sequence makes a certain shape. It just automatically makes a shape. But we've never been able to figure out the physics of making that shape. Yeah. And it's a big problem. And the only way we could determine sort of the correlation was through experimental methods. And this has been the case for the last 70 years. Yeah. But it's also been something very important because, as I say, the shape determines
the function.
And typically, experimentally, it would take about a PhD student, his entire PhD, his or her entire PhD, 5 years to determine the correlation between one sequence and one shape.
Wow.
Right? So it's called folding a protein. So to fold one protein, it would take 5 years. And so...
to unfold.
Yeah, essentially to decode the shape. So it's a complex problem. We don't know the logic. We haven't been able to figure out the physics, but we just know this relationship exists. And you're sort of decoding that relationship is incredibly important to science. It helps us understand the functioning of the protein, and then also helps us in drug discovery, et cetera, to then figure out how to make it. So it's a massive sort of challenge. And in 60 to 70 years of doing this, PhD students mapping it, we had got to about 100,000 proteins.
Of the 200,000?
Of the 200 million.
200 million, sorry.
Yeah, so we'd only mapped 100,000 of the 200 million.
Oh, wow.
Humans, in our bodies, we have about 20,000 proteins.
Okay.
And so that 100,000 didn't contain all of the human proteins, but a lot of them. And, what typically scientists would do, they do a PhD, publish the paper, release it to humanity, and off they go. AlphaFold, which is a neural network-based, a deep learning-based program.
From Google, right?
From DeepMind, Google DeepMind, yeah. They set out to solve this problem, and it's a perfect problem for a neural network. And essentially, they trained a program to have the intuition to map this shape to this thing. And within 2 years, they mapped all 200 million.
Wow.
So they solved a scientific problem with a program that was based on intuition.
That's crazy.
Yeah, it really is.
And what data set did they use to train the model?
So they used 100,000, and this is you now jumping on something really exciting. So they used 100,000 known proteins to train the model. And then they didn't have more because, they need to get to 200 million, right? So they need to now use that model. And the model had to be improved because that training data was too small.
Yeah.
So what they did then is they predicted models and then used that in the training data set based on confidence. So they were confident that this was the next sequence, and then they used that. And then ultimately, within 2 years, they basically did 200 times, even more, I can't even do the maths, 100,000, 2,000 times what humans have done over 70 years. Yeah. And it is an intuition based, it's guessing the shape.
Wow.
And again, this is why I think this is the sort of the error of intuition. Computers are showing us the power of intuition. We've always had it as humans. It's been our superpower. It's been largely ignored by all the sort of traditional systems, especially education. But yeah, this is amazing. It's really changing the world.
That's crazy.
It's cool, eh?
That's very cool.
And I again, like I say, the best way to understand the AI and what's changing in the world is to understand, is to compare it to humans and how humans behave. Then you'll get a sense of understanding how these models behave. So pre-trained, how are the different ways that we train? So if this is a little baby, so if I add all the different pieces, there we go, and one more. So essentially, these are all the ways that a baby is trained, yeah? So the baby's trained, the parent giving feedback, exposure to the physical world, real world feedback as well. So parents give you feedback, but also real world gives you feedback. You put your hand on a hot stove. Yep. Sorry, guys. You put a hand on a hot stove. You get burnt. That's real world feedback. We use all our senses, like you were saying. And then lastly, we do extrapolation, which is, we don't, just because we burnt our hand on this stove, we don't have to burn our hand on every stove to know that, we extrapolate. We say, oh, we're fairly confident based on what we learned here that this is the outcome there. Yeah. And this is exactly how the models are being trained and what's happening. So all the models right now, so the parent feedback is essentially what we did with, the DeepMind, constant feedback. Sorry, the fine tuning of these large language models was done with humans. So parent feedback. Exposure was exposure to all the text. We're going multimodal now. So we now not only
text.
We've got the real world feedback, which is like the deep learning where there's certain rules that you get answer back. And then the last one is extrapolation, which is the synthetic data idea, where you create your own training data set, which is what DeepMind did, as I mentioned now. So all of how humans learn, how babies learn, is exactly how we're training these models. It's just a digital version of each.
Yeah, except humans haven't used synthetic data really. Or maybe it's an imagined.
That's exactly what it is. So
imagined scenarios.
Correct. So I burnt my hand here. I now have created a data set that everything red and hot and making a certain sound, that's extrapolation.
Yeah.
So I've visualized that if I put my hand there, I'm going to get burnt.
Yeah.
And that's now reinforced in my training data set. So now, do you understand? So exactly how humans learn is exactly how we're training these models. And again, as I say, so don't try to understand them as a program, understand them as a human. And
it's a little bit easier to understand.
In this one, yeah. I think the generative one, which is the great example. So this is a picture of a child in an art class. And I tell this story because it's a great way to explain this. Generative models are creating an answer. Yeah.
Okay.
Right. So there's a story of children in an art class, and the teacher said, listen, you can draw anything you want. Yeah. And these little kids were, I think the 5 to 7 year olds were away, they're drawing. And this teacher walked past this one little girl and said, listen, what are you drawing? And she said, I'm drawing a picture of God. And the teacher said, but no one knows what God looks like. And she said, well, they will in a minute. Do you understand? And it's something that I find fascinating. Kids don't lie on purpose. They always generate an answer that they think the parent wants to hear, at least initially. Yeah. So these models are not lying. What they're doing is they trained to generate an answer that they think humans will like, in exactly the same way kids,
My daughter, just reminds me, my daughter told me the other day she chased away a 40-foot eagle.
Correct. And this, we call it, they flip, sort of going between imagination and reality. But the truth is they're just learning the real world by exposure, by trying something with you and seeing the feedback. And that's how they're doing it. So the other thing is something to understand is our memory is not memory like the computers remember. So a computer has a specific part of their chip that is encoded with a certain number. So if you store an image in a computer, those pixel numbers are stored somewhere there. You can there's a physical change to the chip, right? Whereas when we remember as humans, what we've done is we're recreating the feeling that we had when we were exposed to that. So we are generating the output based on our model that's been trained. Yeah? Which is exactly what kids do when they lie. They just don't know they haven't been trained enough to filter, the experience of that.
It's a selective memory.
Correct, yeah. But again, even our own understanding of how our memory works, these models are teaching us. So you're training these models on all of the information, and they can remember most of it. Yeah. But when they're remembering, they're actually generating the answer. So again, this is another aspect for me which I'm so excited about, which is how AI models are showing us about how we are actually remembering stuff. There's no cell somewhere in our body that's encoded with everything that we remember. What we do is we generate an answer that feels right. Yep.
Interesting.
Okay, cool. Lots of concepts. Is it too much?
Yeah, it's not too much. I think it's difficult to. I understand exactly what you're saying, but to kind of say that a computer can learn the way a child learns is, an interesting concept. I understand the concept, but to almost believe it is different.
Yeah, so that's what's, to be honest, that's what's unbelievable about these AI models that we're seeing now. All of deep learning, all of neural networks is fascinating. That is why scientists were getting so excited about it, 6 or 7 years ago. And now at the advent of ChatGPT, kind of the whole human race is now, or everyone exposed to that.
What the hell is this thing?
Exactly. Yeah, it's like, the rest of us caught up about 5 or 6 years after the technology was developed, but the scientists were as excited about it. I want to kind of end with sort of a slide here, which is just showing the comparison between sort of the human brain and the neural networks out there.
Okay. Yeah?
So there's some things that are still incredible about the human brain that we haven't decoded. In fact, there's a lot. But a couple of things. So one, these models are huge and they take megawatts to train. But actually, in terms of number of parameters, the human brain is in the order of 100 times bigger.
The human brain is 100 times bigger
than ChatGPT.
Okay.
Or GPT-4. So GPT-4 has, so models are, the size of a model is basically the number of numbers, the total number of numbers stored in the model.
Okay.
They're called parameters. Yeah. So they have about a trillion numbers stored in the biggest models that we have today. And our brain has 100 trillion.
Wow. Okay.
Okay. So we are 100 times bigger. At the same time, we operate on a fraction of the energy requirement of these large models.
1 megawatt. That's to train?
To train a large language model literally takes megawatts. It's insane. And that's why very few companies... Power plants. You literally build a power plant to run the training on the model.
Wow, I didn't realize.
Because essentially for every exposure. So every time you do a backward pass, you're adjusting a trillion numbers. So what it does is it says, give me an answer. If I don't like the answer, I adjust a trillion numbers. Then it try again. Do I like the answer? And it keeps doing that until I like the answer.
Wow.
That's training. Essentially, it's tweaking numbers, and you've got to tweak a trillion numbers. So it takes megawatts in the computing world, but the human brain does it on 30 watts. 30 watts.
That's crazy.
It's insane, right?
Yeah.
We are incredibly energy efficient. And of course, we can operate in the real world, and models haven't got there yet, which is the AGI threshold. But at the same time, there are some areas where the computing world the digital world is much stronger. So ability to retain knowledge, of course, these models when generating make mistakes, but they can be exposed to and know thousands of times more than an average human. And humans only kind of have one human knowledge.
If I ask ChatGPT a question and I'll get an answer, I get it's not connected to the internet. It's a language model, so it's inferring an answer.
Yeah.
And you ask ChatGPT the same question, would you get the same answer?
If we asked the exact same question and the model was exactly the same at that moment, yes. Because essentially it's a calculation.
Yeah.
Of what?
Yeah.
It's a bunch of numbers. But the problem is like they're training all the time and they're getting your context, my context as we grow. And so therefore it's evolving like a human.
Yeah.
So if I asked you a question and somebody else asked you a question, will you always give exactly the same answer?
No.
And if you ask straight after each other, you might say the exact same answer.
Okay.
But if you asked apart or different people asked and the conversation was different, you'd give slightly different answers each time.
Yeah.
Again, the way to understand this is always to understand it like a human. And the other big problem or the advantage that computing has is that sharing knowledge between models is much easier. It turns out that if you average the weight strengths, so you've got a trillion numbers, and so this model has learned a whole bunch of stuff, and this model has learned a whole bunch of stuff. If you just average each weight, let's say they're exactly the same structure, you average the weights, they both know both of the total set of. It's quite
I didn't follow that.
If you average the weights,
So talking about weights.
So each parameter is a weight.
Yeah. Okay.
So imagine a big structure with all these connections, and each connection has a certain strength. That's the parameter. The number that defines that strength is the number. So if you got two models that are exactly the same, and you train this model structurally exactly the same, and you train this model on one data set, and you train this model on another data set, so you get basically a trillion numbers. Each one has a trillion numbers, all connected in exactly the same way.
So I teach English and Spanish.
Correct.
Okay.
And then if you just average each weight, so this one, let's say this is plus 0.5 and this is 0.3, and you take the average and you create a new model with exactly the same structure that has the average of all of the weights, then it knows both data sets. So it's highly transferable. You can teach the second model what this model knows, and this model what the other one knows, like almost instantaneously, just by averaging.
It's very difficult for humans to do that.
Humans, I have to talk to you, and over time you learn what I'm saying. So the bandwidth of transfer, for you to know everything that I know, even though I write everything.
Learning different languages is an example. Yeah.
Correct. So these things learn much more efficiently.
Wow.
And can be multiplied.
Yeah, it's a computer.
I mean, if I were to try and replicate you, it's almost impossible, right?
Yeah.
Oh, it is impossible. So Jan, I just want to show you one last slide because I think it's an important concept. I think you're getting it, but it's a bit heavy, eh?
It's heavy.
Okay, sorry. So let me just show you one more thing because I think it's also quite an important context to what we're seeing out there. So this is a picture of a graphic design that actually won an art competition, and there was big hoo-ha about this. It was a graphic art competition because it was the totally AI generated. And there's a lot of people talking about copyright because these models are trained on hundreds of or millions of images, and therefore it's not their original work, etc. And the problem here is that it's a misunderstanding of the word copyright, right? So copyright is if I copy what you wrote and use it as my own, then that's copyright. So if you wrote a book and I read your book and I used none of the words that were in your book, but I was inspired by your book to create something, is it copying?
No.
Because that's essentially how all of art has been generated by humans forever, right?
Yeah.
Correct. So that's exactly what these models are doing. Yeah, they are being trained, they're being exposed to
Like humans are.
exactly. We read a lot of books, so it's a complete you copyright, and the concept of IP in the traditional concept of an IP doesn't actually apply, because you're not copying and pasting anything. And this is a big problem now. So it's very funny. Like, a lot of so this what is it called? Stock, the image galleries. I forget. Shutterstock, Getty's Images. I think it was Shutterstock that was trying to sue these models for using their images on training and saying it's copyright. And the problem is the law doesn't cater for this. So it's on the internet. These images are on the internet, so anyone can see them. So if I trained a model looking at what's freely available on the internet, and then it produced an image, it's exactly how humans function. So this is a huge conundrum, but people don't understand it. People think of, I shouldn't show my information for a model. Yeah, you're sharing your information, but if it's using that model for training, it's actually not storing your information anymore.
Yeah, it's learning.
It's just learning.
It's this is where science is gonna butt heads with the commercial side of things.
Correct. Yeah.
Because now, as we saw earlier, you can start to generate any image you almost
correct
want.
And if we start to apply these laws to the digital space, where does the application to the human creativity space now apply? And you've got it now. So if we're saying it's okay for me to write a book having read your novels, and it's not okay for a model to
read your book and
write
learn
novels.
something, yeah.
So I have to be able to monitor whether this was written by a model or me.
Yeah.
Which is, like we said, based on distribution, virtually impossible.
Oh yeah, the world is certainly uncertain.
Correct. It's fascinating. And for me, the most exciting thing about AI is how much how close it is to the way humans behave, and how much it's showing us about how we itself are.
I'm glad we spoke earlier on the potential upsides.
Yeah.
Obviously, we focus. You look at the top 4 or 5 questions on Google; they're all negative, right? Yeah. And I'm glad you spoke about the opportunities, and especially in underprivileged environments, how AI can create an opportunity not only to be equal, but also go beyond what is currently, the education system. So speaking of the internet, we had quite a few questions from our social media platforms.
Yeah.
So I'm not going to ask all of them because I think you've covered a lot of the topics. So this one was pretty interesting. How do we safeguard job displacement, balance innovation with compassion?
So I don't think
from Aiden.
Okay, so to Aiden, I don't think you can safeguard job displacement, because the current jobs are probably not going to exist, in the future. So I think they're going to be different jobs out there. So it's like saying, if AI was going to create sort of the best personal doctor in your pocket, the meaning of doctor and the human participation in being a doctor has to change. Yeah. Just like we no longer plow fields manually because, so I think jobs are going to change. And I think the second part, which is how do we be compassionate about this, is an element of, I think this sort of new change that's coming is going to force us to really understand what it means to be human and what's our kind of purpose. Yeah.
Yeah.
There's the very negative example in that movie Dali, yeah, where the dystopian future where humans, all they do is sit and eat all day and watch TV. I don't think that's the human purpose, and I don't think we would be satisfied with we would be able to be sitting all day to doing nothing. And I think we've just got to start answering that question. What is it? What is our true strengths as humans, and what do we want to do with our time if we had a choice?
Yeah. I also think that there's often a misconception as to which jobs are going to be lost.
Correct.
Because we come from a world where for the last 6 years we've been automating. You spoke about the plow
Correct.
versus the tractor.
Correct.
That's an automation step,
Correct.
which has been going on for a long time now. But AI changes thinking jobs.
Correct. Intuition jobs.
Yeah, intuition jobs, not necessarily production jobs on the shop floor. So everyone thinks about the shop floor being disrupted, which could be the case, but I think more likely or sooner would be the intuition jobs, the thinking jobs.
Yeah, I mean, think about
even if it's a data capture, reading a number that somebody has written on a piece of paper and capturing that as an example.
Yeah, think about it. It's so funny. We've made the most significant advances in computing and computing capability in the last few years. And the first jobs to be laid off now are the tech jobs. Google and all of these companies are now laying off jobs, essentially because AI is making them redundant.
Yep. Okay. Javier asks, he's thrilled about AI personalizing our online experiences, but at what cost to our privacy? Where do we draw the line? You kind of alluded to this, but maybe answer more directly.
So I think there's, I think the privacy angle is a distraction, to be honest. Privacy is very important to all of us, but in machine learning, knowing the name of the data set is not that important.
Yeah.
As it's not necessarily that important. It's like, does Google really care park Google, but does Amazon really care the name of the person who bought the product or the fact that they bought the product? So this privacy side of things, I think, is a distraction. I think I
think it's mixed up with social media.
Correct.
So there's a privacy issue with social media.
Correct.
Using your personal information to manipulate or whatever that is.
Correct.
And that's being mixed and muddled up with AI data sets.
Correct. So there's the data set idea and my privacy. But also I think we're going to come to a point where nobody will believe any imagery on the internet.
I mean, look at the first pictures that we looked at.
Yeah. And if you can't tell the difference between real and fake, then our dependence on trusting an image or our tendency to trust an image. So it's almost like if there was an image out there of me doing something, pretty soon in the future, that's not going to hold up in court even.
Yeah.
So again, I think a lot of this sort of focus on privacy is probably distracting from the real threats of AI. Because I think privacy is not that important in the AI space, in the development space. I think there's so many other things that we got to worry about.
Cool. You've also kind of answered this early on, but I'll ask it anyway. Maybe you can be more specific. Excited about how AI will revolutionize my career trajectory, but how do we ensure it's accessible to everyone?
Yeah, I think it's probably going to be the most accessible technology ever, just by luck, actually, rather than by the nature of it, rather than by any human sort of intention.
And yeah, the fact that you can put it on a smartphone and be offline makes it extremely scalable.
Correct. And cheap.
And cheap, yeah. I didn't quite get the essence of this question, or I didn't quite understand this question, but I think the essence is, how do we know the accuracy of these models? So if we're going to rely on them to do our jobs, to infer an outcome, how do you rely on it?
Yeah, so I mean,
that's
again,
from Anil, by the way.
Yeah. So Anil, I mean, when you get somebody to trade on your behalf, how do you rely that they're going to do the right thing? when you ask your doctor for a doctor's opinion, how do you know they're going to get the right thing? We are comfortable based on a certain level of achievement that we trust that opinion, right? And some history and so on. So it's so funny. It's like if we try to get autonomous vehicles to be perfect, right?
Yeah.
That's a never-ending journey because that's the logic-based, rule-based. It succeeds, it either wins or it doesn't.
Yeah.
Or you can get autonomous vehicles to be much better than the collective human population. Would you deploy them? My opinion is I would deploy them.
And it will save millions of lives.
Correct. So I think it's a mindset shift that we need to make. It's not about only implementing when it's 100% correct. We just need to reference it to what is an acceptable level, like we've been doing with all humans since the beginning.
We choose the best, not the one that's perfect.
Correct. And we're quite happy to accept that there's no perfect human.
That's an interesting concept. Accepting the best, not the one that's perfect.
Correct. Because you're coming to a point where the complexity of situations means there's no correct answer.
Yeah.
And again, this is our training. We always look for the correct answer, even though we know in the real world and we're so used to an environment where there is no right answer.
Well, logic outputs a correct answer based on that logic. So this is different, right?
17 years when you did a test at school, there was a right answer and there was the wrong answer.
Exactly. I got all the wrong answers.
Correct.
Yeah.
And it didn't help you with preparing you for life.
Yeah. I think this was probably the most popular question from Fatima. AI generating art is fascinating, but how can AI truly understand human emotions, the human emotions behind creativity?
Oh, this is a great... emotions, people are very protective of emotions in the human space, yeah? And I just want to start, there was a great example where, going back to the doctor space, because I love this doctor space, it's something that we depend on, but is very much based on intuition, yeah? So,
although we tell ourselves it's based on logic.
Yeah, there is a certain training set, but ultimately the doctor makes a gut call.
Yeah.
And we're okay with that.
No, I think that we're okay with it because we think it's a logical call, but it's actually a
maybe
gut
you're
call.
right. Yeah. Actually, you're right. We've been trying to think.
I go to the doctor. He's been trained. He's now gone through. He's asked my symptoms. So the logic is telling me, or his logic is telling him that it's that. But actually, it's his gut feel
based on his experience.
I've accepted because I think it's his logic.
Correct. Yeah. That's a really good point. Maybe we're fooling ourselves into saying there's logic behind every decision. Yeah. Okay, so the question, sorry, can you repeat?
AI generating art is fascinating, but how can AI truly understand the human emotions behind creativity?
Yeah, so again, I go back to using the human. How do we understand emotions?
Yeah, we don't.
We don't, or we do. And whatever we don't and we do, for me, the computers can emulate. So let me put it this way. They can understand emotions at least to the human level.
It's better than me.
Yeah. And some of us are really bad at EQ. And the example I wanted to give you earlier was that we had, there was an experiment where they had a bunch of kids engage with a doctor and get answers, at a university. When I say kids, I mean students, yeah. And ask them for help and so on. And half of them got human responses and half of them got AI responses, like our our thing. And when they were surveyed, the students, most of the students found the AI more empathetic.
Oh, really?
Yeah. So again, these are spaces where we feel that it's, what does it mean to be human? And the whole new wave of neural networks is actually bringing that into the digital space. So if anything, the computers are more emotional and more intuitive than they've ever been before.
Yeah, you look at that image.
Correct.
And it feels like it's been driven by an emotion.
Correct, 100%. And that's why it wins
The outcome.
art competitions. And there's a lot of people who say, oh, but ChatGPT is bland and it's not really creative and so on. And I think it's a matter of time. But I think...
Well, look at that image.
Correct. The models are getting better. And the more better they get, they will certainly, compete, if not outcompete humans to a point where we can't recognize the source.
So my last question, Ajit, is what to not ask you to predict anything, but what advice would you give anyone out there, whether it be a person in school, university, in a job, not a job, retired? What would you say they should do in this AI space?
Yeah, that's very easy for me, Jan. I to get strength, I look to how kids navigate the world. Yes, there's parents to protect them, and certain guardrails, but they have this energy for exploration and discovery that we've lost through our education system, or we trained out. And I really would encourage everyone to get into this and have a mindset of, not a mindset of I'm going to learn to be an expert, but I have a mindset of I'm going to learn because I want to play. I want to go back to how children sort of learn. And I truly believe it's a very human behavior. So just play.
Explore.
Just explore. Just get in. Create things with the tools. Add something, form opinions, and contribute. Yeah. And you don't need to be an expert because there are no real experts out there. I hate being called an expert because I know how much I don't know.
Yeah, that was clickbait.
Yeah, absolutely. I mean, but that's the point. Is that we just try to be a 5-year-old in the space, and you will explore and enjoy it, and you will thrive in the moment. As I say, kids play without being asked to play, and what are they doing there? They're learning.
Yeah, Ajit, thanks a lot. It's been fascinating. I'm sure we could keep talking.
I would talk for 2 days, and I sorry if I ramble, but it's something I'm obviously really passionate about and excited about.
I think at this rate of change, we need to have you back sooner than what.
Everything will be outdated in a few weeks. Yeah, absolutely.
Thanks.
Thanks so much. It's been awesome.
Awesome.